In this session, we will discuss about different implementation aspects of pre-trained models for computer vision as well as related technologies associated to deep learning. In this session, we will see by which way we will be able to integrate pre-trained deep learning models, computer vision models, or even NLP based models for research based applications using free and open source libraries. As all of you are already aware, you might have worked on machine learning, you are already aware with Python programming. You might have seen that classically for deep learning based implementations, either we use PyTorch or TensorFlow. Along with that, lots of other technologies associated. OpenCV is there, BoofCV, Theano. So we will see, first of all, we will discuss about different use cases of pre-trained models for research projects, whether you are working on some particular research task, academic research project, or corporate research project related to computer vision, natural language processing, speech recognition, biometric analysis, gestures, behavioral analysis. And in addition to that, you might have seen that nowadays we are in the era of generative AI. In this session, we will discuss about that part also, how to integrate large language models, retrieval augmented generation with pre-trained implementations. Along with that, we will discuss about very important terms, very important concepts in computer vision in deep learning, like transfer learning, fine tuning of some particular models, fine tuning or transfer learning of pre-trained models. If you are working on some custom model, for example, you are working on satellite data and you want to take some pre-trained model. So in that particular pre-trained model, your images are not available, obviously. So how to put our own data, how to freeze or unfreeze the layers. So to some extent, we will see about that particular part, because in online session there are certain constraints related to implementations. So I will try to cover some particular implementations in which few images can be inserted and those we can train. And along with that, we will see how to integrate large language models, retrieval augmented generation, vector databases, because nowadays we are in the era of generative AI. In generative AI, lots of AI platforms available: ChatGPT, Gemini, Stable Diffusion, Dale, thousands of platforms. At backend of these, there are pre-trained models. But when we discuss about pre-trained models or backend models of ChatGPT, Gemini, Bard, or Google AI Studio or Notebook LM, then we do not use very classical term pre-trained model, because that is not a small model. These models are a huge model, giant models, big models, and those big, giant, or huge models we relate with large language models, and each and every large language model is pre-trained. At backend of ChatGPT, you might have heard that LLM is working. But what is actually that LLM? That is a pre-trained. That is pre-trained from so many books, from millions of books, from millions of tweets, millions of articles, so many web scraping. After that, that LLM is trained. But at the base level, that is large language model. So we will see that part. And when we integrate real time searching, when we integrate real time data extraction, real time addition of data, then it is associated with a particular term that is known as retrieval augmented generation. When ChatGPT was launched around 4 years back, you might have seen at that particular time only particular data associated to some particular timestamp it was available. Real time search was not available initially around 3 to 4 years back. But nowadays, when we are searching something on ChatGPT or Gemini, they are fetching data from its large language model, from its pre-trained model. Along with that, it is fetching data from Twitter, Facebook, Reddit, so many websites, and after that it is augmenting, it is adding the data in its pre-trained model. So in real time fine tuning is going on, in real time that transfer learning is going on. So what we were doing around 5 to 6 year back, manually by transfer learning, by fine tuning, these things are going on in real time nowadays in chat gpt. Whatever we are searching, if it is new to chat gpt, it will fetch data from internet, it will add it. Add means fine tuning, transfer learning, retraining, and then it will give you prediction. And with this particular concept, with these specific concepts, there is one more term that is known as vector database. We should be clear about this particular term. If you are working on research projects, if you are teaching to students, we are guiding some minor projects or major projects, we are preparing our students for their better placements, then rather than classical databases like Oracle, MySQL, or SQL Server, nowadays vector databases are working at the back end of pre-trained models. Which are those vector databases? So, however, this particular topic I will cover separately when we will discuss about cloud deployment. So, this one, Pinecone, Milvus, FAISS, and so many other vector databases. Nowadays, at the back end of pre-trained models, giant models, large language models, vector databases are used. You can see that if we are working on generative AI based applications, generative AI based applications for computer vision, for speech, for whatever it is. So even if you are working on IoT based applications, for example, I want to fetch real time signals from sensors, I want to fetch real time data from some specific hotspots or some specific sensing area, some satellite. In that case, we have to work with these applications: Milvus, FAISS, Facebook AI similarity search. You can see that these are vector databases, and nowadays in industrial applications, in research based applications, these are used. So you can see its performance, how many queries are associated. Okay, so these terms, these concepts we will discuss, and in few lines of code you can see that in 4 to 5 lines of code we will see how to train a particular model, how to work on pre-trained models, by which way we will be able to add our own data and working with vector databases at backend. Along with that, there are so many other platforms like Clips. Okay, Clip platform, that also we will discuss. Now, dear participants, first of all, we will discuss about some real world scenarios, some use cases, implementation aspects of pre-trained models where we can use. As all of you are academicians, you might be working on some research projects, whether these are funded projects or social projects. Many times we work with Arduino, BeagleBone Black, or Raspberry Pi, and so many other open source hardware available. And we generally strive or struggle for good research ideas. So, such type of research projects we can integrate, we can implement using low cost hardware with computer vision. All of these applications are computer vision based applications. You might have seen in defense based applications, in law enforcement based applications, drones are used. Okay, however, drone technology is associated with IoT, Internet of Things. Okay, along with that, we use a high quality wireless network, 5G. Nowadays 6G is also under research. But by which technology we will be able to capture data, by which technology we will be able to match certain target. For example, we are proposing a research project, we are working on a particular task like swarm drones. So obviously a particular target should be shot down, target will be target will be matched only if our computer vision based application is working fine. For that, we can use pre-trained model. For example, I'm having some sensors, I'm having a particular drone architecture, we have integrated each and everything, but by which way we will train the data related to target? For that, we will use computer vision, opencv based applications. In military operations, you might have seen these are widely used in almost every sector. These are already integrated. Okay, these are not only associated with IoT, because when we see such type of devices, such type of robotic applications, we think that these are IoT based applications. But along with, because IoT can't work independently, along with IoT, we must need computer vision. You might have seen in different cricket matches, particularly IPL matches, and there was a particular robotic dog. So this is also a computer vision based application. However, there are sensors, some particular actuators, some specific devices. Okay, it is connected to satellite, it is connected to base station, but by which way it is identifying the obstacle, by which way this particular robot is identifying the direction, in which particular direction it should move, left, right, it should not collide with any player, it should not collide with ball, or it should not collide with any boundary wall. It should be independent, it should be moving independently, taking care of the obstacles in surrounding. Taking care of the obstacle means computer vision. Okay, so if we want to work with such projects, in that case we have a very good option of integration of pre-trained models. Pre-trained models means all objects of this world, each and everything, each and every image related to the world, it should be available in a database. Now, for example, we want to work on this project, we want to work on this particular task, drone based application or robotic dog. In that case, by how it is possible that we will train each and every object in a particular database, in a particular model? Different types of trees, different types of human beings, different height, different types of obstacles, how it is possible? So if we will work on this particular task manually, we will have to train millions of images. For example, we want to work on a robotic application for home automation, for our home task. In that case, we will have to train each and every object, each and every image, like refrigerator, okay, AC, chairs. So there are so many different types of images. How it is possible for any researcher to take snaps of different types of images and then train it? And after that we will put it in Raspberry Pi or whatever it is. rather than working from scratch, rather than reinvention of wheel. What we can do, we can take help of pre-trained models. Pre-trained model means it is having all images of this world, all animals, all creatures, each and every type of object, whether it is living object, non-living object, and after that it will work not only for law enforcement or entertainment. We can work, we can integrate in manufacturing sector. In speech recognition also pre-trained models are used. You might have seen, uh, even you also might have used Amazon Alexa. What is Amazon Alexa? At the back end of Amazon Alexa, there is pre-trained model. It is able to identify what you are saying, what is meaning of your sentence, what you want to say with your particular statement. And after that it will identify your instruction and it will perform the action. Same thing happens in case of Fire Stick, Amazon Fire Stick. We want to we want to watch YouTube, we want to watch a specific web series, we release audio, and that audio is recognized with a pre-trained model. So pre-trained models are not only for computer vision or speech recognition, for every sector, even AI integrated medical devices nowadays. You might have seen that mobile integrated ultrasound machine is deployed. If you will explore a machine with name Butterfly, okay, so handheld or pocket based ultrasound machine, similar to you might have seen nowadays almost every chemist, almost every medical shop is having a particular device to capture BP level or sugar level, diabetic level. Same way, ultrasound machines are available handheld. However, there are so many security, privacy, and integrity issues. So many social issues are also there, because there may be threats also if such machines are deployed for general public. Because everybody, in that case, everybody will be able to perform ultrasound without any doctor. But such things are available, and all of these are working with help of pre-trained models at the back end. As just now we have discussed related to chat gpt, Gemini. At backend of Gemini, at backend of chat gpt, there is pre-trained model. Okay, but that is huge model. So many books, so many articles, millions, trillions of sources are extracted from different di- millions of research papers are put in a particular pre-trained model, and then we are asking the questions. Okay, so these are application areas, whether it is number plate detection. Okay, so you can work on these intelligent applications for agriculture. So for these applications also, we must need computer vision, real time object detection, real time crop analytics. You want to see growth of a particular crop. Okay, along with computer vision, you can we can fetch some particular chemical data, some specific data related to humidity, temperature, or other aspects in that particular farming area. Okay, so all of these aspects, all of these implementations are associated with computer vision. Along with that, IoT, because nowadays we are in the era of multidisciplinary research, interdisciplinary research. We are in most of the segments, single domain research is not going on. Almost every person is working on multidisciplinary research. And for multidisciplinary research, we have to integrate different technologies, computer vision with IoT. Okay, computer vision with blockchain, IoT with blockchain and computer vision. Okay, so whenever there is a task related to security of biometric. Okay, biometric is related to computer vision, but security of biometric features with blockchain. It's broadcasting, it's communication, that can be done with IoT. So such type of interdisciplinary, such type of merged approaches can be worked out for research based applications. Okay, now we will see, if we want to work with these applications, we want to work with some realistic research projects, then which are key phases? These are the key phases. Okay, if we want to, if we discuss about broader aspects, broader way, in broader way, this is the format. Okay, either we work on pre-trained model. For example, we want to work with robotic application. In robotic application, either we will work on pre-trained models, or we will work on custom model. Custom model means I don't want to take any pre-trained model, I don't want to take any pre-built images, I want to take my own images. In that case, we will go for custom model. I will work on matrices, we will work on algebraic equations, we will work on some particular tensors manually, but it is very time consuming and performance will be a very big issue. Generally, in custom model, in self-created models from scratch, we face problems of performance accuracy. But if we are working on pre-trained models, in that case, we generally get very good results. Okay, in most of the research projects, in most of the research-based applications, we work with pre-trained models. Pre-trained models means different models which are already trained on different data sets. Okay, now if we discuss about different libraries, so many libraries available which provides you pre-trained models. OpenCV, BoofCV, okay, Luminoth is also there. So you can see OpenCV. Is this audible and visible to all participants? Kindly confirm in chat window. Well,
Yes, sir.
are you getting the content properly? Okay, so you can see whether you are working on biometric application or any other application. So either you can work on OpenCV, SimpleCV, YOLO, Lobe, BoofCV. So many platforms available, and different cloud-based applications are also integrated. Now, first of all, we will see which pre-trained models are available very quickly. So only two to three slides I will show you now. After that, I will come directly to implementation part. Okay, we will see how to work on pre-trained models in practical demonstration, and by which way we will be able to work on fine tuning part, because that is very important. Fine tuning, transfer learning. What is pre-trained? Pre-trained models means these models are already trained on millions of images on a huge data set. One of the very popular data set is ImageNet. Okay, ImageNet data set, CocoNet, uh, Coco data set is also available. So you can see that this one, ImageNet data set. What is at the back end of ImageNet dataset? You can see that millions of images, training images. How many validation images are there? It means if I want to work with robotic application, for example, I want to develop, I want to work on a robot, I want to work on a drone. So to recognize any object with object recognition algorithm, obviously I will have to train the database, I will have to train a particular model. So rather than taking own images from on camera, what we can do, we can take these images, these are already available and pre-tested, 1000 object classes. These images are also already integrated, all data sets, coco data set, Coco dataset images. So you can directly search Coco dataset. This one, common objects. At backend of pre-trained models, these data sets are integrated. So all animals of this world, all types of creatures of this world, all living objects, different types of non-living objects. For example, I want to work on a robotic application for home automation or for smart office automation. Obviously, I will have to give each and every image to that model, that this is refrigerator, this is AC, this is cooler, this one is washing machine, so that it should not collide with that. It should be able to identify that it is a washing machine, it should not collide. This is a leaf, it can collide, because if that robot will collide with leaf, then nothing will happen. If it will collide with some dust particle, nothing will happen. But if it will collide with some tree, then that robot can be damaged. So by which way we will give so many images, how to train each and every image, first of all taking image and then training. Rather than that, we can directly take these models. These are pre-trained models. Exception, VGG16, VGG19, ResNet, these are pre-trained models. And at back end of these pre-trained models, so many images are already available. Simply in 5 to 6 lines of code, in 10 lines of code, we will be able to work on a particular object recognition based application. You can use any of these. Okay, so these are classical pre-trained models. Classical pre-trained models means each and every object. For example, I want to recognize. Okay, I will show you its demo also. So many images I have already taken, like fingerprint, MRI images, X-ray. For example, I want to predict what is this. Okay, whether it is a car or not. Okay, so this one, whether what is this particular object? I want to predict this object. So by which way we will be able to predict? For example, I want to predict this particular object. There are so many types of cars, so many types of vehicles in this world. How it is possible that we will take image of each and every vehicle and then we will train? Rather than taking our own images, what we can do, we can use pre-trained model. In pre-trained model, it is already given that if this is the shape, then it is a car. If this one is the shape, it is some particular creature. If this one is the shape, then it is MRI. If this one is the shape, it is X-ray image. If I'm working on some particular data like medical data, satellite data, for example, this is my satellite data. Okay, dense forest. In that case, we will we will have to work on fine tuning part. Okay, so first of all, very quickly we will see by which way we work on these models. So some models, first of all I will show which models we generally use. These are general purpose pre-trained models. General purpose models, AlexNet, VGG16, and how many parameters are there, how many layers are there. Layers means how many accuracy. For example, I need high accuracy. Okay, very high accuracy. In that case, 201 layers. You can see that. So high accuracy layer based pre-trained model I will use. How many parameters are there? ResNet. These are general purpose. Now in these general purpose, there are every type of object. Okay, there are insects, human beings, different types of creatures, different types of vehicles. Okay, but for example, my area of research is X-ray images, pneumonia based X-ray images, or cancer based some particular ultrasound, or some cyst based MRI. In that case, what I will do, many times we have seen that new researchers, particularly new researchers, they directly use these models, these pre-trained models. Okay, without taking care of the aspect whether their data is fit or not. Okay, randomly many people use ResNet, randomly people use VGG19. Okay, for example, my area of work is iris detection. Okay, so for iris detection we can use any of these, but which is best fit? This is the list of best fit models. If I am working on eyes, then VGGnet. Skin, VGGnet. Brain, lungs. If we are working on ultrasound, then Inception model, endoscopy, Inception. Okay, so for different type of diseases, for different types of objects, for example, I want to work with satellite data. Okay, in that case we can use VGGNet. We are working on some geospatial data. In that case also we can use VGGNet, AlexNet. So we have to see which particular type of pre-trained model will be fit. Okay, now we will see if how to integrate these models in code, and once these codes are working, after that we can put it in some open source board, whether it is Raspberry Pi or Arduino Beaglebone or whatever it is. Okay, so this is the list. At end of this session I will share this presentation to all of you. So if you are working on chest x-ray, then ChexNet, dermatology based implementation, Inception v3. Okay, so for different type of diseases, for different types of problems, different types of data sets, we have to select a particular pre-trained model. Okay, for example, I want to generate some particular text. So in that case we will use Gemini or chat gpt. If I want to generate images, then we will use Dale, stable diffusion, so many other. So which large language model, which particular pre-trained model we want to use, that we have to select. Okay, so at end of this session I will share this ppt to all of you, in which this list is available. And if I want to integrate it with IoT, so in that case we work with MQTT. For example, real time computer vision, with computer vision pre-trained model, and those pre-trained models we want to link with particular base station, we want to link with IoT scenario. For that we can use MQTT, message queuing telemetry transport, for IoT and its integration with computer vision. Now we will see some implementations, and then it will be more clear to all of you what we want to say. So some codes I have already prepared. So at end of this session I will share these notebooks also. So connect, this is Google Colab notebook. Now very first implementation I'm showing you related to prediction of some objects. For example, this one is some image that is taken, that is fetched from some webcam, from some CCTV, from some camera in drone or robot, whether it is robotic dog or drone or whatever it is. We want to predict what is this. Now, without training any particular model, without training any data set, what we are doing, we are taking care, we are directly fetching pre-trained model. So see this code very carefully. I will show those points which are associated to pre-trained. You can see that we are using PyTorch. Okay, for, you can see that load pre-trained model, models.resnet, resnet 50. So you can see that it is, this particular code is only 15 to 20 lines of code. And in this particular code, we have directly imported ResNet 50. In ResNet 50 at backend, which database we are using? We are taking the database of this ImageNet classes. You can see that this one is ImageNet classes. This ImageNet classes.txt file, what is inside this? This is taken from this portal. Okay, so in this particular web link, each and everything is available. So you can see that all labels. Okay, millions of images are already trained. So in a single line of code, download image net labels, we have given its URL, which pre-trained model we are using. For example, this is ResNet 50 model we are using, pre-trained. This is true, it is pre-trained model. Pre-trained model means we are not training any data, we are not giving our own data. It will take care of the data. It will link data from ImageNet dataset from this portal, this one ImageNet. Okay, and I am giving only test image, test.jpg. Where is my test.jpg? This is my test.jpg. Now I want to see what is this image. Okay, what is label of this particular image. So on execution, it will ask me to upload the image. Okay, so it is executing. So you can see that it is fetching. And so ResNet 50, this particular model is linked. Now I will upload the image which I want to predict. Okay, which specific image I want to check. Okay, test.jpg. Now you can see that it is giving me probability. This one, it is a sports car, this one is racer, and these are the labels. Okay, in same way, for example, for some other image I want to predict any other image. Okay, now I'm taking this one sq. This one is sq.jpg. Okay, now I want to predict. Now whether it is a robotic dog or drone or whatever it is, we want to predict what is this, and depending upon this we want to perform some action. We want that that drone should perform action, whether to collide, whether to fire some weapon, or to change the direction. Okay, first of all it should know what is this. So this image we are checking with pre-trained model. Okay, so this one sq.jpg. So in this particular code we have not given any particular label. You can see that it is fox squirrel, highest value it is associated with fox squirrel. But you can see that in this particular code we have not given any squirrel database, we have not given any car database. Okay, only few lines of code, and those scripts, those syntax are related to fetching the pre-trained model. Okay, so this is known as working on a pre-built model, on a pre-trained model without giving our own data. We will give our own data only for prediction. Okay, whether you want to use it for computer vision or speech recognition. Okay, for speech recognition also you can use. For example, you want to work on sentiment data analysis. Okay, in sentiment data analysis, for example, this one. Okay, so this is also the implementation. This one is also associated with pre-trained model. Transformers are also associated with pre-trained models at the back end. Okay, so either you can import complete model, or what you can do, you can link a transformer. So what is a transformer? Transformer is an architecture, is a neural network architecture. At back end of that neural network architecture there is a pre-trained model. Okay, which pre-trained model? Sentiment analysis. You can see that in 4 to 5 lines of code I want to predict what this particular text is all about, whether it is a positive or negative. For example, we are working on sentiment data analysis, emotion data analysis, polarity score. We have some Amazon reviews, Flipkart reviews. We want to predict whether these reviews are positive or negative. So what we will do, rather than giving each and every word, rather than giving each and every label, what we can do, we will use this pre-trained model via pipeline. Okay, so what is transformer? At backend of transformer there is pre-trained model, and transformer is an architecture. So you can see that, and to use that transformer we use pipeline. So you can see, first is this movie, the movie was not good, it is negative 99.97%. It is out of 1, so out of 100% it will show, it will be 99.97% negative. And second review, product is good, it is 99.98% positive. Okay, even if you want to work on some chat gpt like application, some generative AI based application, if I want to summarize it in chat gpt, in gemini, many times we work on text summarization. Okay, so for that purpose also we can work with pipelining. Okay, what is pipelining? Pipelining is the way to use transformer. What is transformer? Transformer is using a pre-trained model. Along with it in which data is already available, data is already trained, and then we want to predict something. Okay, so for example, we want to summarize this particular data. So you can see that in only 5 to 6 lines of code. So if we want to develop an application similar to chat gpt, so which model we are using, this is the model, and where these models are available. Now the question comes, from where we will come to know how many total models are available, how many types of models available, where list is available related to pre-trained models or corporate models. There is a website, there is a portal, that is Hugging Face. Millions, okay, so many options available. So you will get so many different types of pre-trained models available here. You can see that for audio to text, text to audio, text to text. If you are working on computer vision, depth estimation, object detection, image classification. For example, we want to work on image classification. In image classification, which model I want to use? Okay, which specific model we want to use? So all corporate models are available here. You can see that different corporate models. Which model, which pre-trained model I want to use? Google VIT, Microsoft. If I want to work with NVIDIA model, you can see NVIDIA. Okay, I want to use OpenAI, that is the developer of ChatGPT. You can see Microsoft ResNet. This Microsoft ResNet 50 that we have used in code. This one. Okay, just now we have used same thing in code, but it is actually available on this portal. Okay, for example, I want to test this pre-trained model. Okay, this one. Simply upload the image. For example, I want to see what is this particular object we want to predict. So it will give me probability. So this one is car, sports car, 0.991. It means 99.1%. Racing car, this one, car wheel. In same way, for example, some other object like this one, bike. This is, you can see, disc brake, moped, motor scooter. Okay, this one. So if I want to use this model, if I want to use this pre-trained model, so they have given the transformer in form of transformer. So one way is that one way to use this pre-trained model is to take its complete code. Okay, and which particular database they have used at the backend, which specific model they are using. So you can see, first of all, we will check which database it is using. It is making use of coco dataset. You can see that it is also making use of coco dataset. Along with that, imagenet classes, it means merger of both coco as well as imagenet. So they are also using pre-built images, already pre-built images, and this is the code. So if I want to use this pre-trained model in my robot, in my drone, so I will integrate, we will use this pre-trained model in form of transformer. You can see this is transformer. So what is transformer? It is the way, this is the method, it is the architecture to use a particular model. Which model? This one. You can see that from pre-trained Google VIT base, from pre-trained Google VIT base, and in 6 to 7 lines of code, we will be able to train our robot, we will be able to train our machine or any particular device, whether it is a drone or whatever it is this clear to all of you? To some extent, kindly confirm. To some extent, is it clear to all participants up to this point? Whatever.
Yes, yes.
Yes, sir.
Okay. Because in a short time span, it might be difficult, but I'm trying to cover these points. Up to this point, are you getting the content properly and speed is fine? Are you understanding the concepts or not?
Yes, yes.
Sure, sir.
Okay, now, dear participants, we will see. one very important point. So these are pre-trained models, so and millions, so many models, hundreds of models available. For example, I want to see OpenAI model, OpenAI pre-trained model. You can see OpenAI GPT, OpenAI GPT OSS. So if I want to take a particular model that chat GPT is using, that Gemini is using, so we will be able to use. If you want to work with some context based models, in that case we use model zoo. Context based models, context based models, you can see model zoo. For which application you want to work? For example, I want to work with X-ray. My area of work is related to X-ray images, so it is giving me that pre-trained model. You can see that chest X-ray, and click. It is on the basis of ResNet. So you can see that ResNet 50 is updated. If I want to work with MRI, okay, so you can see that this one for MRI, brain segmentation, SegNet CMR. Okay, so browse categories. You can see in which domain you want to work: computer vision, reinforcement learning, natural language processing, or any other. So this one. If I want to use, for example, this particular model, okay, this. So simply click. It will give you the code, get model, and this one is for pose analytics. Okay, in form of transformer we will be able to use it. Now dear participants, we will come to our point that is very important as per the current scenario of research, that is known as large language models. Nowadays we are in the era of generative AI chatbots. For almost every application, you might have seen chatbots are available for content creation, image creation, multimedia content. If you want to generate lecture notes, you want to generate presentations, for each and everything, for each and every application, chatbots are available. Now, we want to link generative AI with our own data set. Okay, we will come to that particular part. So, first of all, I'm downloading this notebook and I will share to all of you. We will work on computer vision based application for image indexing in large language model retrieval augmented generation. First of all, we will see what we are going to do. Okay, I'm having some images. Okay, so in very first demonstration, we will work on clip based implementation. Clip means contrastive language image pre-training by OpenAI. Interconnection or linking of images and text in same embedding space. What is meaning of this? First of all, we will make this point very clear what we want to say with this statement. You might have heard, you might have studied that when we work on classical databases, we take a particular data type. For example, I want to store some number. We use integer, long integer, short int, or whatever it is. If I want to store date, we use date data type. For name, we use char, varchar, or whatever it is. For images, we use lobe, blob. We do not integrate images and text in same. In classical databases, we can't store image data as well as text in same field. For example, we have defined a schema. Okay, why we are discussing it? Because when we go for pre-training, when we go for generative AI, where is our database? Database is at the backend and it is in form of vector database. Vector database means it can embed everything. It can embed video, it can embed text, images in same embedding space. No need to separate that this is image, this is text, this is video, this is calendar, it is date of birth. Each and everything will be on same space. That's where the concept of optimization comes, performance. That's why chat gpt, gemini, they are giving you very quick results, because at the back end vector databases are working, not classical database, sql server or mysql or ms access. So what is the vector database? Vector database means each and every data will be converted to vector. Vector means number, some particular numeric format, some particular vector format, it will be converted and it will be stored at the backend. Chat GPT, Gemini, Bard, AI Studio, whatever it is, Dale, Stable Diffusion, each and every AI based application nowadays, they are making use of vector databases at the backend for storage of data, for pre-training. Okay, now what we are doing, what we want to perform in this particular implementation. Okay, first of all, I want to upload some images. For example, I'm having these images, few cars I will upload. This one is car, bike, squirrel. Okay, and in 5 to 10 lines of code, not very lengthy codes. Using vector database, it will be automatically identified whether it is a car or a bike. It means no need to extract features. Features will be identified automatically. For example, I am using these fingerprints. I'm uploading these five fingerprints, and I want to identify a particular type of fingerprint. One way is that I will train it. I will have to convert in a particular matrix format. We will convert RGB to gray. After that, training, so many other things in classical deep learning. If we are using convolutional network or RNN, rather than using convolutional network, rather than using RNN, we can directly use vector database. Vector database already knows each and every pattern, and that is the major performance aspect nowadays. So we will see this particular part. So first of all, I am installing these packages. FAISS, OpenClip. What is FAISS? For storing the features of the images vector. So this is Facebook AI similarity search. Okay, this one, FAISS. If you want to use Pinecone, Pinecone can also be used. Vector database. It will automatically identify the vectors. Okay, so you can see that this one, and these are available in open source distribution. Many databases are available in open source distribution. Okay, no need to pay anything. You can see open source vector database for generative AI based applications. For example, I want to create a pre-trained model for my institute, for my organization. Okay, so rather than using Oracle MS Access, I will use Milvus, I will use Pinecone or Clip. Okay, so that each and every feature should be identified automatically. Now pip install PyTorch, FAISS CPU, and open Clip Torch. So this interfacing we will use. Now some images we will upload. So this description also I have given here. Okay, so first of all, so I'm directly coming to that particular part. Some demonstrations related to realistic images. Some forest images I want to upload. Okay, satellite images. So very first implementation we are working on satellite images. So this one is first image, satellite image. Just demo I have taken. First image, second image, third image. Okay, these three images we have taken. These four images. Okay, these four images I want to train in vector database, and then we want to predict. So for uploading we are using google.colab import files.upload, and with os.make dir we are creating a directory so that these files will be uploaded. Okay, now I will run it, and I'm taking those images. So s1 to s4, these four images I am uploading. These four satellite images I have uploaded. Okay, this uploaded s1 to s4. These are s1 to s4. Now out of these s1 to s4 I want to get prediction. I want to fetch dense forest area. If I am working on classical deep learning, classical machine learning, or classical computer vision, in that case it will be very time consuming, taking features, then segmentation. After that, we will go for some particular activation function. After activation function we will see performance, then fine tuning, so many things. But if we are creating a model with clip, with vector databases, in that case your model will be very very fast, and quicker results you will be able to achieve. So you can see that this one, open AI pre-trained model we are using. Which model? So this one, VIT B32, it is pre-trained OpenAI, and where we want to store the data, we are using at the backend clip. Okay, clip. And now on execution, we want to see the retrieved images. Okay, so which query I have given? Dense forest area. I want to see only those images which are associated to dense forest area. Okay, so this query is similar to the query we give in chat gpt. Okay, so if we want to give it a graphical user interface similar to chat gpt, gemini, or dale, that can also be done with gradio, with streamlit. Okay, so this particular query we are giving, and you can see that out of four images, three images are extracted. We have uploaded four images of satellite, but dense forest area is associated with this one. These images are associated with dense forest area out of four. Okay, top matches. By which way it is going on? Using clip matching. Using clip. And where is clip? You can see that it is a pre-trained OpenAI tokenizer. Which tokenizer it is using? VIT B32. Okay, so what we are doing, we are directly taking a particular pre-trained model, and we are simply uploading our images for analysis. In same way, for example, we want to work on fingerprints. Now I will show, first of all I will show you fingerprints. Okay, this one is first, second, third, fourth, fifth. Five fingerprints I want to train in my model. First, second, third, fourth, fifth. These are five images from f1.jpg to f5.jpg. So five fingerprints I will upload with google upload files. Okay, so f1 dot from f1.jpg to f5.jpg we are uploading. With files.upload we have uploaded. Now I want to extract particular fingerprint like curve based. I want to see a particular fingerprint curve based or some particular pattern. That particular pattern we will specify in our query. So where is our query? So this is the query, loop pattern fingerprint. I want to extract only those fingerprints. So you can see that we are not training any data. We are only giving the reference of pre-trained model of OpenAI, and it is create model and transform open clip. So what is open clip that we have just discussed? It is taking the index, it is creating vector of each and every image, and you can see that in very less lines of code. And we have given loop pattern fingerprint. This is my query, loop pattern fingerprint. In loop pattern fingerprint, these three images are given. I have uploaded five images. Out of five images, f3, f4 and f1, these are extracted related to loop. These are three loops, loop based. Okay, if I want to see other whether others are also loop based, so this is not, so this one is not loop based. Okay, so out of this is not loop based, this one is loop based, this is loop based. Okay, so out of five images it has identified this one. If I want to see, okay, if I want to give any other query, so we are directly querying on that particular database which we have just given. And without any GPU, we are not using any graphic processing unit, we are not using any graphic card, we are not using any TPU, simple CPU with classical CPU we are working. Okay, loop pattern fingerprint without loop pattern. Now we will see this one. Okay, so fingerprint, curve fingerprint. Now in curve fingerprint, f3, f1 and f2, we want to see those images. Okay, top similar images. So similar images to this particular, and now this. These three images are extracted similar to a specific particular query. So curve fingerprint. Otherwise, if you will perform it in manual implementation of deep learning, it will be very time consuming. We will have to work on, first of all we have to work on pre-processing. Whether we are working on deep learning or machine learning, first of all we have to pre-process the data cleaning, transformation, after that segmentation, then feature point detection. But with vector databases, with this particular library that is nowadays used in chat GPT, that is nowadays used in OpenAI or AI based applications, it is doing each and everything automatically. Okay, clip, contrastive language image pre-training. So along with your classical implementations you can integrate, and it is also a matter of research also. You can propose, you can write very good articles, very good papers on this. For example, comparative analysis of clip and classical image retraining, classical image training and performance evaluation. So one implementation with classical deep learning, with classical convolutional network, results can be fetched. Another implementation with clip. Okay, what is execution time in this, what is execution time in RNN, CNN, GRU, what is how much accuracy we are getting in this, how much accuracy we are getting in classical deep learning. So what we can do, some results we can fetch, comparative evaluation. And if we are confident that this particular demonstration, this implementation is working fine, then obviously we can propose it in future work. So these type of demonstrations. So one more implementation, for example, we want to work on some medical images. Okay, for example, some medical images we are having, we want to display, for example, this one, x-ray issues, only those images which are having x-ray issues. I want to train I want to train this one sec 1 2. Okay, this one x-ray 1, this one is x-ray 2, and this one is MRI. Okay, some MRI images, some x-ray images we have trained, and after that we want to predict, we want to fetch only those x-rays, only those images which are having certain issues, pneumonia or whatever it is. Okay, whatever disease, whatever diagnosis aspect, whatever or whatever disease we are analyzing, that we can identify. So in these we can use pre-trained models. So rather than working on pre-trained models, ResNet, GoogleNet, VGG16, what we can do, we can take these models, and these models are available on Hugging Face. Along with that, you can work with Model Zoo, hundreds, thousands of models available, you can directly use. Okay, so you can see that for depth estimation, for zero shot classification, for text summarization, that ChatGPT is doing nowadays. Okay, text to speech, text to audio. For example, I want to work on text to speech. So on this, so which model I want to use, I want to use Microsoft model. So this one is Vibe Voice from Microsoft. In same way, I want to use AOIoT. Okay, that can also be done. In same way, if we want to take any other model, like for computer vision, okay, only for computer vision, like image segmentation, image to video, video classification, mask generation, image to 3D. Click in image to 3D, you can see Microsoft model is available, Facebook model is also available. If I'm working, so as a new researcher, what we can do, so one implementation of Facebook, one implementation of Microsoft, one implementation of NVIDIA, comparative analysis. In that case, our comparative analysis work will also be done with good results, with actual results, rather than theoretical content. Okay, so you can see stability AI. This can also be implemented. So if I want to use it, so in that case, its transformers are available. Okay, so models, and in which programming language you want to work, you can go for filtering also. Okay, different filtering we can apply. So libraries, for which library I want to work, PyTorch, TensorFlow, JAX, Transformers, or Namo, Fast AI, YOLO. Okay, or task based. If I want to work with image to image or object detection, in object detection, NVIDIA model, I want to see this NVIDIA model. So this is NVIDIA. Okay, I want to use it. So this is the code. This one is script. This code is given in form of API. Okay, transformer is provided. We can put it in our Google Colab. Once it is running, then we can put in Raspberry Pi, Arduino, or whatever it is. Okay, wherever we want to deploy. We want to deploy it as web-based application, that can also be done. Okay, we want to deploy it on cloud. For example, this one, I want to check this specific. Okay, so we have uploaded. This is DataNet, DETR, and by which way we have to use it. This one code is available, and now you can see car 96%. If I want to deploy it, so train Amazon SageMaker, we can link it with Amazon SageMaker. If I want to deploy on spaces, okay, you can see that use this model as a transformer or Google Colab notebook or Kaggle kernels, so in form of transformer. So this code is, you can see that in 5 to 6 lines of code. From transformers import pipeline, pre-trained model is debtor ResNet 50. If I want to use it in my collab auto model for object Facebook debtor ResNet 50. Okay, so here it is written. If I want to use from a OpenAI, so we will use OpenAI VI whatever it is VI 32. Okay, that specific name we will put. If we want to use it in Google Colab notebook will be available. Okay, so these pre-trained models are widely used in corporate sector also. So you can see Qualcomm companies, corporate, they are also working on, they also integrate these uh, pre-trained models for gesture recognition. Okay, rather than training your own model, training your own data, after that we will see what is confusion matrix, how much accuracy is there, how much error is there. It is very time consuming, and even after performing so many things manually, we do not get very high accuracy. So rather than reinvention of wheel, we can take these pre-trained models and we can deploy. Okay, we will discuss about deployment of these models on cloud also in next session. Okay, I will discuss that how to create its web-based application. For example, this application I want to create its GUI, I want to upload it on a web browser. Okay, so you can see that, for example, this clip model from OpenAI VIT B32, now it is working on only Google Colab. In next session we will see, I want to create its web-based application. I want to open it on web browser, so that there will be a browse button. It will ask me to upload the images. It will ask me to write something similar to Chat GPT, and then it will give me prediction. So that part we will discuss in the session related to deployment of machine learning on cloud. Okay, in that we will discuss about 4 to 5 platforms, 4 to 5 different libraries using which we can create its GUI application. Okay, graphical user interface application for if I want to create its dashboard. Okay, because currently for research purpose it is fine. It is working on Google Colab notebook or it is working on console. That is fine. But if we want to give it professional interface, browser interface, we want to give some buttons, we want to give some text boxes. In that case, we will have to use it on cloud. So in next session we will discuss about that part, deployment of deep learning and machine learning on cloud. Okay, so you can explore these tools, and now dear participants, I am sharing this presentation and notebook to all of you, so that you will be able to use it, and its link I will share in chat window. Kindly wait, and after uploading it I will share its link in chat window, and then session will be open for your queries. Dear participants, I have uploaded this presentation, and its link I am sharing in chat window. Dear participants, simply click on this link and download, and kindly confirm whether this presentation and notebook is downloadable or not. Simply click on this link and If you are not able to click on the link, then scan this QR code from your mobile phone. You will be redirected to this page where presentation and code is available. Now kindly confirm, is it accessible or not. Simply scan this QR code from your mobile phone and you will be redirected to this page, and kindly confirm, is it downloadable or not. And now session is open for your queries. If you have any query, you can ask. Whether this presentation is downloadable or not, kindly confirm. Whether you are able to access this URL, simply scan this QR from your phone. I am again sharing this QR in this format so that you will be able to see it. Just a minute. I am showing it again in this way. Okay, now dear participants, session is open for your queries, and if you have any query, you can ask. Meanwhile, you can scan this QR code to download this presentation and notebook. Any query from participants?
Good evening, sir.
Yes, ma'am. Good evening.
So mine is very simple question, sir. Sir, there are many libraries, more architectures, and many things are there, sir. So, what path to be followed to master in computer vision? Sir? Is there any particular path to excel in computer vision?
Okay, ma'am. To work in computer vision in a professional way, you can start with OpenCV. Actually, when we work with OpenCV, then most of the algorithms related to image processing, these are already available. Along with that, our base concepts should also be clear. So, base concepts, paradigms of image processing, any textbook you can take, and as far as implementation aspect is concerned, OpenCV, and after that, from OpenCV, you can directly move to vector databases. Okay, but
Okay, sir.
to start, as far as complete information is concerned, detailed information is concerned, you can achieve with OpenCV also. Okay, in OpenCV, each and everything can be done. Even video processing can also be done.
Okay, OpenCV is sufficient to
Yes,
learn
yes,
computer vision, sir.
yes. OpenCV is more than sufficient. If you are able to work only 60% of OpenCV library, your more than 90% work will be done. Okay, because it is a very huge library, thousands of algorithms available.
Thank you so much, sir. Thank you so much.
Any other query? And whether you got something or not, I don't know whether how many of you are aware with these terms, vector databases, RAG, LLMs. To how much extent you are clear, you understood these concepts, you can tell, you can message in chat box also.
Hello, sir.
Yes, ma'am, please.
Yes, your session was really very informative and engaging. So, I have one query. Um, Actually, what kind of predefined model should we use if we are working with the real time bio waste analysis? Uh, So you
For
have told us that we can use this VGGNet for this fundus image or OCT image analysis,
yes,
and for brain MRI we can use AlexNet, right?
yes, yes,
So,
yes.
I am actually I was searching for this, but I have not got much data sets. So, as there is a lack of like scarcity of such data sets, and also privacy issues are there, right? So, can you tell me?
Okay, actually, ma'am, in that case, you can work with ResNet, GoogleNet, AlexNet. These are very popular pre-trained models. And at back end of these ImageNet, Coco dataset, these are
Hmm.
already integrated. So you can start with this. Okay,
Okay.
once you take start with these platforms, with these libraries, then you will be comfortable to adopt other libraries. Okay.
Okay.
First of all, you should take start. Actually, what happens, we have seen that many times, specifically new researchers in any technology,
Hmm.
they fear, they have a fear of starting. They have fear of initiating. Actually, what they do, generally, what people do, taking code from different sources and running it. But when we want to create our own code, then we get stuck rather than directly taking code and executing very small code. You can try, for example, only single image. Take one example, training only two images and prediction of single image. Actually, this code will be of 10 to 15 lines, but that 10 to 15 lines of code will clear your concepts. It will give you confidence. It will boost your confidence. If I will take a source code of 500 lines of code, 200 lines of code, in that case, we get panic. Okay, so see, do not panic on starting with some implementation. So take very small implementation like hello world. Okay, by which way we have to work, then two images, three images, and then move ahead. After that, your concepts will be very, very clear.
Okay, sir.
Okay, and
Thank you, sir.
nowadays chat gpt is available, nowadays copilot is available. Okay, in
Yes.
copilot, you can generate very simple code. Okay, any other query from participants?
Sir,
Yes, yes, ma'am.
hello.
Yes, ma'am.
Sir, good evening, sir.
Yes, good evening, ma'am.
Sir, very simple question I have. In image classification, sir,
Yes.
which model I should use, and which one I should use pre-trained model also?
For image classification, ma'am, you can start with ResNet or AlexNet. Okay. If you want to train your own images, if you want to go for fine tuning, in that case,
Okay.
what you can do?
ResNet, na?
Yes,
ResNet 50.
ResNet and AlexNet you can use.
ResNet and others. Okay, but should I use pre-trained model also?
Yes, ma'am. These are pre-trained models. ResNet, AlexNet. These are pre-trained models, and if we want
And
our own data, then we go for fine tuning. Actually, what is difference in fine tuning and transfer learning? In case of fine tuning, we unfreeze all layers, unfreezing all layers, and then we retrain. In transfer learning, we change only two to three layers, last two layers or top two layers, and then we go for its predictions.
oh, okay, sir. Thank you.
Any other query from participants? And if you have any suggestion, you can message any suggestion, any point of discussion. You are open and you are most welcome.
सर जो आपने पीपीटी दी है वो खुल तो गई है जो आपने गूगल वो दिया है उसको ओपन कैसे करेंगे डाउनलोड हो गई है ओपन कैसे
Yes,
करेंगे
ma'am,
फिर
you can download it. So is it visible, ma'am? Is this visible? You can see that in
सर वो
more
डाउनलोडेड में तो दिख
download. You can see.
डाउनलोडेड में दिखा रहा है
हाँ जी. In download file, and after that you can directly open it.
ओके अभी तो डाउनलोडेड में दिखा रहा है ओपन नहीं हो रहा है बस
Okay. Actually,
Madam, this is the zip file, so you need to unzip.
Okay,
ओके
if
ओके
you don't, if you need direct PDF file, then rather than clicking on download files, you can click on this more individual file. Okay, in that case it will be in PDF. Okay, download file, if I want to download this file independently, more download file. Okay, then independently this file will be downloaded. Any other query from participants? You can.
Sir, is there any platform to master in OpenCV?
Yes, ma'am. From open, from OpenCV portal, you can access its documentation. Okay, in opencv.org, you can go for documentation. Its
Hello?
official documentation is available. Hello. Yes, ma'am.
Sir, is there any
On open.
is there any platform?
Yes, on
Yes, sir.
OpenCV documentation, you will go for it. Okay, so you can see that this one I am resharing my screen. I'm showing you.
Okay, sir.
Okay, OpenCV documentation. So you can directly search for OpenCV documentation, docs.opencv.org, and here you will get everything. Okay, what you want to do, you want to work with machine learning, you want to work with deep learning in OpenCV, all APIs are available, all scripts are available, and its documentation, detailed documentation is available.
Thank you so much, sir. It was very informative and new things I can able to learn out of this session. Thank you.
Thank you, ma'am. Any other query from participants? If you have any query, you can ask. Session is open for your queries, and after that we will conclude this session.
Hello.
Yes, yes, please.
Sir, good evening. Is it plausible to share the meeting link through mail also, sir?
uh, Actually, that particular content will be shared via coordinator. So from coordinating team, you
We
can discuss.
are posting in WhatsApp only. Sometimes WhatsApp has some problems, sir. So you can share both WhatsApp and email, sir.
Okay, okay, sir. I will send an email and WhatsApp also.
Actually, because of this WhatsApp, some issues, sometimes it is not open.
Okay, so I will send in mail also.
Okay, okay. Thank you, thank you.
Okay. So if there is no more queries, then should we conclude this session? Kindly confirm.
So, what is the future of AI, sir? It's a general question. It is like more related to ML, DL, computer vision. So, what would be the future according to you,
And
sir? As you are a
as far as future is
industry expert.
concerned, you can integrate with large language model, and actually it is already implemented. Dale, Stable Diffusion, and so many other platforms are available. They are making use of generative AI. So integration of computer vision with generative AI with large language models, creating your own RAG. There is one concept that is known as model context protocol. Okay, retrieval augmented generation. So what we can do, we can create our own chatbot, we can create our own AI based application. Okay, on platform that will be able to identify the images, that will be able to take decisions automatically depending upon that specific image or object.
Using RAG, sir,
Yes,
we
yes,
can implement this.
yes. RAG and MCP, Model Context Protocol. These are related to generative AI, large language models. So, if you are doing research in this domain, then you can link it with RAG. Okay, and but to work with RAG, we have to be comfortable with Pinecone. Okay, in next session, I will show how to work in Pinecone. how to work on Milvus, and how to deploy it on web browser, how to deploy it on as a web-based application.
Okay. Thank you, sir.
Thank you, ma'am.
Sir,
And
I have one last query.
yes, ma'am,
Sir,
please.
is it possible to get your contact details so that we can connect with you after the session gets over also?
Yes, ma'am. In presentation, I have shared my contact mail ID is given. So if you are facing some issue, you are stuck at a particular point, you can mail me, and I will be happy to assist you. I will try to troubleshoot, and
Okay, thank you.
you can
Thanks so much.
contact. No issue.
Okay,
So
okay.
my mail ID is given, and if you are working on some particular concept, so try to integrate the recent technologies. If you are doing research, actually every teacher is a researcher, every professor is a researcher. We, so we have to take care of recent technologies, we have to adopt latest technologies at the back end. Generally, you might have seen, if you are already working with computer vision, with uh, deep learning, machine learning, generally we use Excel sheet, CSV file, or text file, JSON file, XML file. Nowadays, we are working on vector databases. Okay, so we have to migrate to latest technologies. Okay, rather than classical features in Excel sheet, classical features in CSV file. Okay, those days are gone.
Mm-hmm.
So, and obviously, as a teacher, as an academician, many times we struggle for good publication. So, good publication will be okay. Good publication will be successful only if we will adopt latest technologies. Okay, so integration of computer vision with RAG, then submit your paper. Definitely, so there will be more chances. Okay, we are not saying that it will be sure shot, but more chances will be there for good publication in Web of Science, Scopus, or SCI.
Okay, okay. Thank you, sir.
Thank you, ma'am.
I have a question. So, will the result be consistent? Like, for example, you have shown an example where you have taken five fingerprints, and then three of them were loop based or something like that.
Yes.
So, if I run it again and again, will it be always this three, or it may come to at some point? Because two of them looks more like loop, like
Yes.
to our eye. Uh, so I have that question. Will it be consistent or not? Like
Ye-
suppose it is cat and dog. If the one image is given cat as 70% and image dog as say 30%, but again if I run that, will it be same or it'll be different?
No, no, it will be same. Actually,
It will be always
yes, it will be consistent. There is no issue in consistency or integrity.
okay, sir. Thank you.
Okay, so
And
you can,
another question,
and
sir.
as far as
Yes,
actually these platforms are in beta stage. You might have seen lots of platforms are in beta stage, in initial stage. So in that case, so that's why we are saying that it is a matter of research till these platforms become too mature with so many publications. Before that, you can hit and trial, you can go for different permutation and combination, and only then we will be having good publications, good research projects. Are you understanding what I mean to say?
yes, sir. Yes, sir.
Actually,
Thank you, sir. So
currently,
another thing, like you said,
yes, please.
yes, sir. Like we have used a pre-trained model, but can we do our optimize, like can we train that model with our data set that is,
Yes, yes,
that maybe,
yes,
huh?
definitely anything you can update, any number of
So
images,
that
any type of data.
the one that you have done, the one that you have shown us, that was just you're directly using the pre-trained model without uh,
Yes,
training your data set, right?
yes.
So
Uh,
if
we
we want
can,
to do, say,
we
suppose,
can
yes, sir.
if I want to give my own data, that can also be done. If we want to fine tune,
Okay. Yes.
if we want to retrain it. Okay, so that code also
Retrain it.
I'm sharing. Should I share that particular code also?
Yes, sir. That part also we would like to learn, and I would like to learn means that where I can do my part also. Like I can train it and it will be still, it won't be too many codes, no, because I've
Yes, yes.
already, or it will be like developing from scratch, or it will be.
Yes, yes, I am showing you. Is it visible, ma'am? Is this visible? This notebook.
Yes, sir.
In this, some scripts I have generated. So I will show you first of all, and then I will share this notebook to all of you in same link. After some time, you will be able to refresh. So this is fine. This is pre-trained model without any fine tuning. Is this visible, ma'am? ImageNet, which is 16. This is without fine tuning.
Yes.
Now I want to fine tune it. This is without fine tuning. Now I have some images. This is the folder cat, this one, two images, dogs. So what I will do, I will upload to that particular folder in zip format. Once it is uploaded, then we can go for prediction. So full retrain. What is fine tuning? Full retraining. In full retraining, what we are doing, we are unfreezing all layers. Unfreezing all layers where it is given. So you can see that unfreezing everything, fine tuning full
Okay,
model.
sir.
Okay, so this notebook also I am sharing you, so that you can experiment something. Just a minute, on same link I will upload full retraining and transfer learning. So this is full retraining,
Full model. Okay.
and this one is transfer learning with your own data set. Okay, simply upload your zip file and start go for its prediction.
Yes, sir. Thank you so much.
Just a minute. I am uploading on same link. First of all, I'm checking where is that link that I have shown you. I think this one on same file bin link. I will upload.
Thank you so much, sir.
Just a minute. Okay, on new file bin link I am uploading, because previous link is not opening now. Is it audible and visible to all of you? Is this audible and visible to all participants? Am I audible to all?
Hello.
Am I audible to all? Kindly confirm. Is it audible to all of
Yeah,
you?
yeah.
Yes. Yes, sir. Yes, sir.
Actually, there was some network issue. So,
Yes, sir.
Yes.
okay, I'm uploading that fine tuning and transfer learning part. Now, dear participants, kindly confirm, is it downloadable or not? Scan this QR code again. This is a new QR code. Mm, This one, new QR I am generating. Just a minute. Kindly confirm, is it scannable or not? Simply scan this QR to download this notebook, Google Notebook, Collab Notebook, and is it downloadable? Is this notebook downloadable with transfer learning and fine tuning, retraining with your own data? In this code, every instruction is given how to upload a directory and how to predict. Is it downloadable? Kindly confirm.
Sir, can you give the this link in chat
Yes,
box?
yes, yes. Link also I am giving, and you can see that this QR as well as link, both I have given this QR code as well as link, and kindly confirm, is it downloadable or not? Is this opening, sir? Gautam, sir?
Yes, sir. Yes, sir.
Okay.
This is downloading.
Okay, and other participants, is it downloading? Kindly confirm. Okay.
Yes, sir. It is downloading.
Okay. So if you have any query, you can ask. After that, we will conclude this session.
Sir, if you permit me, I'll ask one simple question, sir.
Yes, please.
So, what is your opinion if someone wants to switch their career from teaching to industry? Suppose if someone wants to work on computer vision because technology is every day updating. So, can a teacher can switch their career into computer vision, sir,
Yes,
as
ma'am.
a fresher?
Definitely, ma'am. You can go for that. In that case, your programming skills related to Python, related to OpenCV, these should be very good. And along with, and not only with computer vision, you should be able to work with IoT based programming also. Because in industries, in corporate world, multidisciplinary research is going on. No, whosoever is working on computer vision, they are not only working only on computer vision, because whatever application, whatever device is having webcam or CCTV, it is linked with satellite. It is associated with wireless technology. You might have seen in matches, cricket matches, football matches, computer vision based robotic dogs are available. Okay, these are deployed, but these are not arbitrary, these are not independent, they are connected to satellite, they are connected to base station. So when interconnection is there, we need some wireless programming. So if you are comfortable in these, then you can definitely go for that. And obviously, as far as corporate world is concerned, industry is concerned, there will be more opportunities. Okay, so it depends on self interest, whether you are interested more in teaching academic tasks or industrial applications.
Okay, sir. So for we need to practice project on projects also. We need to work on latest projects also, no, sir,
Yes,
to
yes,
excel in this.
yes, definitely. Because when you will try for industry, if you will try for corporate world, they will see your assignment, they will see your portfolio. Okay, how many projects you have done so far, which type of implementations you have done. So you have to showcase your research work. You have to showcase your implementations. Okay, so try to integrate Raspberry Pi, Arduino board, some sensors, and then definitely you will be able to migrate to industrial ventures.
Okay, sir. Thank you very much, sir. It is really informative session.
Okay, thank you, ma'am. Any other query?
So I think
Very
there is
good
no
evening,
more.
sir.
Sorry, and
There is one question only I want to ask, if you permit me.
Yes, ma'am, please. Sure.
Yeah, thank you so much, sir. This is Dr. Bharti Kaude from Pune, Maharashtra. Uh, Whatever sessions, previous session as well as this session, both were very insightful and informative. I'm requesting for the PPTs and the contents related to these Python DL related course. My question is regarding, uh, can you suggest what kind of agencies who could provide the fundings, research project fundings? Surely we can get in terms of certain projects related to machine learning, AI, IoT, and all these together, so that there are more chances of getting the fundings from the research for the research project.
Okay. So, ma'am, in corporate as well as government sectors, both there are multiple agencies, multiple enterprises. So, Mighty is one of that. I think you many participants here might have applied their Mighty. Okay, earlier DST was associated with giving research fundings. If you want to work with corporate applications, with industrial applications, then many companies, many IT companies or interdisciplinary research based companies give fundings. Microsoft is also associated with that. So what you can do, what is the best method, okay, rather than naming 3 to 4 companies or 3 to 4 organizations, what you can do, you can adopt, you can download a web scraper. Okay, in chat gpt also scraping is available. Python script, or in with Python also we can go for scraping. What we can achieve with scraping, we in a scraper you can give a particular condition, you can give a particular query wherever certain research funding related to your domain is available, whether within India or outside. it that particular notification you will get on your mobile number, on your WhatsApp or your email, because every day so many companies are coming to picture for research fundings. On LinkedIn also you can search. Okay.
Okay.
So, but major thing is that we should know how to fetch data. So, data fetching means scraping. So, with Google AI Studio, with Chat GPT, you can create a scraper. So many scrapers available. Okay, so those scrapers will find uh, your responses corresponding to your query from throughout the world, and after that you will get notification. For example, 20-30 notifications you are getting, and then you can select, okay, here you can apply. Are you getting what I mean to say?
Yes, sir. Yes, sir.
Okay, so some scraper you can adopt, and that is the best approach. Otherwise, 3 to 4 companies, 3 to 4 government sectors, government agencies we know, and these are not sufficient. If I say very clearly, because if you will apply for MIT, if you will apply for AICTE, DST, we don't know whether we will get funding or not. Okay, because so many things associated, so many parameters
Yes.
are analyzed,
Yes, definitely.
because
Yes.
so many parameters are analyzed in those fundings. So rather than focusing on 2 to 3 agencies, simply scrape entire world wide web and get the notifications, then select which is best. Okay, if
Yes,
you
sir.
will apply to
Definitely.
20-30 agencies, 2 to 3 definitely will respond to you, and they will give you very good amount, they will fund very good monetary values.
Yes. Thank you so much, sir, for your suggestion and valuable inputs. Thank you.
Thank you, ma'am.
Good evening, sir.
Yes, good evening, sir.
sir. Actually, I belongs to mechanical background, sir.
Okay, sir.
But I am interested to vision based this driver behavior analysis, sir.
Okay, fine.
So by that's why I joined this workshop, sir.
Okay, sir. So in
So
this, I think you might be working on drowsiness detection or sleep detection, something like that.
yes, sir, yes, sir, yes, sir.
Okay, okay. Actually, lots of work is going on in this particular domain. However, it is very difficult because as a research project, it is very good for research funding. It is very good, but in realistic implementations, you can understand how much it is implementable, how many people will be able to adopt it. So if we are proposing such type of research project, then in that case try to associate with some government agency, and that government agency which is associated with law enforcement, so that whatever proposal you are giving, it should be applied in government sector, it should be applied in RTO. Okay, otherwise so many research projects are buried in files. Okay, thousands, lakhs are research projects are applied, research fundings are given, so many research papers are published, but these are under files. We don't know how many are implemented in real world. So but if you will try, if you will give some project, if you will give some proposal in association with some government agency, whether it is a transport agency, because if you are working on some drowsiness detection or some behavior detection, because nowadays so many accidents are going on every day, we are coming across news with so many accidents, and obviously as an academician, as a researcher, we should contribute, we should give some solution to these problems, and solution not only in form of a research paper, solution not only in form of only article, solution that should be applied by government agencies. So try to associate, try to apply to some particular agency in association with that corresponding department, with that respective department, so that they should apply. For example, you are proposing some drone application, some defense application, so try to associate Ministry of Defense, Ministry of Transport, Ministry of Education, whatever corresponding department is associated, so that those ministers, those policy makers should come to know that this is the policy, this is the solution, and we can adopt. And definitely it will be a social contribution, it will be contribution to nation, it will be contribution to country. Okay, rather than only publication.
Yes, sir. My question is how this computer vision we can apply, sir. Like now LLMs are coming.
Yes, actually, as far as implementation is concerned, you can start with open source boards, open source devices like Raspberry Pi. Very small projects you can propose, like, because in Raspberry Pi, in Arduino board, we can integrate webcam, and once webcam is in, for example, we are proposing some device that should be integrated with every truck, that should be integrated with every driver seat, in front of every driver seat, in which there will be a webcam. That particular webcam will see what this person is doing, whether this driver is eating something, that is drinking something, or doing something, or taking some nap, micro nap. So that object detection, real time video analytics, so such type of projects, and matching with some pre-trained model. Okay, if that particular person is taking a nap or eating or take consuming something, then it should be matched with some object in large language model or pre-trained model. Okay, so something like that you can propose, and you can show some mini demonstrations. If you are working in some organization, you are teaching some students, so you can take a group of students, group of good students, you can ask them to develop such projects, mini projects, minor projects, or major projects, and those projects you can apply in form of a patent. Okay, patent, once it is granted, then you can move ahead for corporate application, for corporate deployment or government deployment. But first of all, we should start from scratch. We should start from mini projects, very minor projects, so that we can understand. First of all, our idea should be clear. What we want to do, whether driver detection, driver face detection, because because so many complications are also there in this. For example, you are developing some, you have developed some device or some software for object detection, for face detection, for drowsiness detection, for somebody's emotion detection. Then some person can say that my face is always like this. Okay, my face features are always like this. That I have consumed something. So because so many things available, so we have to take care of this part also, because it is one of the major challenge. In emotion detection also, many people says that my face is a sad face, all I am serious person all time. So we can't say that this person is depressed, this person is under depression. Okay, because so many challenges are there in these things. Still it is a matter of research.
Sir, Gaurav sir.
Yes sir, please.
So actually, time is already crossed, so
Yes sir.
we can
Yes sir.
conclude the session.
Yes sir, sure sir.
Okay, thank you, sir, for your nice deliberation, and thank you all participants. So tomorrow again we will meet at 6 p.m. So thank you all.
Okay, thank you
Okay,
sir.
sir. Thank you, Gaurav sir.
Thanks to all participants.